Robin and I built two different JESD204B data converter to FPGA systems that we're going to walk you through right now. These implementations will give you a good idea of how 204B works and what you can expect out of it for your designs.
Here we have the Xilinx KC705 connected to the ADI interposer and standard ADI 9250 eval board. We have one dual channel AD9250 capturing samples, framing, scrambling, doing character replacement, 8B10B encoding, and serializing the results to 5 gigabits per second and driving that over both connectors to the FPGA.
On the KC705 board, the Kintex 325T FPGA does the reverse to deserialize and decode the data. The FPGA also does the sync signal handshake with the AD9250 to initialize the link and get deterministic latency for coherent sampling. Inside the FPGA, the Xilinx 204B IP core outputs the decoded parallel sample data on an AXI stream interface. This data could immediately begin to be processed in the FPGA, but in our design, Analog Devices has implemented a data formatter and DMA engine to move it via the AXI bus into DDR3 DRAM attached to the FPGA. From there, the Microblaze soft processor inside the FPGA takes over.
Yeah, in this design we have Linux running on Microblaze, streaming data over to visual analog over Ethernet. Here we can look at the performance results of the converter powered by the FMC connector connected to a real working system where you can download the entire project and integrate the pieces directly into your design. And here we'll do the same for a native FMC card.
In this case, we have a 9250 FMC card from Analog Devices. It has the FPGA mezzanine card connector right on it, so it can directly connect onto one of our FPGA evaluation kits. We have it here on the ZC706. This card is like the KC705 we just showed you, with lots of great peripherals around the programmable device, but instead of a Kintex FPGA at the heart of the card, there is a Zynq all-programmable SoC. This is a 1 GHz ARM dual-core Cortex-A9 processor with FPGA fabric and MGTs around it on the same die. The FPGA fabric and MGTs are programmed with the same Xilinx 204B IP core and ADI example design we used before, but the difference is we now have a much more powerful hard processor on the device instead of the soft Microblaze processor we used before.
Over the 3 videos we have introduced JESD204B, shown you 2 working implementations you can download and integrate, and provided you some tips for your next design challenge. For more information, check out ADI's Wiki or the Xilinx Lounge. Good luck with your next design.